Hello everyone, welcome again. Today we are together for another practical workshop session on smart technologies for food waste monitoring and reduction. Submodel is identify available digital tools including mobile apps and tracking technologies for monitoring food losses and improving inventory management. Our learning objectives are comprehending technical technologies to be able to explain the technical working principles and applications areas of digital technologies such as IoT sensor, RFID tags, and others. Analyzing digital transformation, strategic tool selection, data simulation and reporting, and financial sustainability analysis. As we began our presentation, the following question has likely crossed your mind, probably. Why is an industrial and organizational psychologist and HR specialist conduct a technical training session focused on technology and food waste? The answer lies in the fact that digital transformation and operational efficiency are, in a sense, human change process rather than mere technological revolution. Food waste management is not a matter that can be solved solely through sensor and complex algorithms. For it's the human element that designs these systems, interprets the data and converts that information into concrete saving action. As an industrial psychologist and HR specialist, I'm here to build that invisible yet critical bridge between technology and people. Without the improvement of the organizational climate, employee motivation, and profound behavioral change, even the most advanced smart system in the world cannot deliver the expected efficiency. In this training, we will not only discuss what technical but also address digital literacy, breaking the resistance to innovation, and how to build a culture of efficiency within this enterprise. Strategic problem solving and adaptability are our greatest assets in preventing food waste. Our goal is to crown technology with human competence and vision while contributing to the economy of Turkey and other nations and environmental sustainability. Yes, let's start. Today we are discussing not just a management model, but a technical mindset shift in the fight against food waste. In today's world, food waste is not merely a line item of financial loss. It is a multi-layer crisis with ethical, environmental, humanitarian, and technical dimensions. The first and most vital step in addressing this crisis is precisely monitoring the losses occurring through the food supply chain. Digital food monitoring systems provide a transparent and constantly measurable structure for the product's journey from farm to fork, from farm to fork. The core philosophy of this system is to make the invisible visible. Micro-level losses that are impossible to detect using traditional methods are transformed into concrete operational data through digital sensors and advanced data analytics. This traceability maximizes food safety while providing business with unique agility in optimizing their resources. This data-driven strategic approach establishes a full-fledged control mechanism in modern food management by eliminating randomness and uncertainty. When we look through a technical lens, we see that the weakest link in traditional food management is manual records based on human observation. Manual system create three fundamental bottlenecks in operational process: human error, data latency, and the lack of data integrity. An inventory clerk misreading a temperature value by a single degree of or a being entered into the systems hours later causes change errors that directly threaten food safety and trigger waste. Digital systems fundamentally solve these chronic problems by automating them within the framework of standard operating procedure SOPs. We saw it before. Digitalization minimizes risk arising from the human factor while guaranteeing data accuracy through software validation rules. This transformation moves the business operational memory from notes on paper to a digital database that can be queried instantly and levels no room for error. At this point, it's necessary to mention AI power systems. AI power systems not only help in collecting data accurately and without errors, but they also provide insightful analysis and powerful data-driven prediction for the future. Furthermore, AI-powered systems eliminate the need for specialization, making it possible for everyone to have knowledge of the data. This very important point. When we look through a technical lens, we see that the weakest link in traditional food management is manual records based on human observation. Manual systems create three fundamental bottlenecks on operational process: human error, data latency, and the lack of data integrity. An inventory clerk misreading a temperature value by a single degree or a form being entered into the system hour later causes chain errors that directly threaten food safety and trigger waste. Digital systems fundamentally solve these chronic problems by automating them within the framework of standard operating procedure and with AI, of course. Digitalization minimizes risk arising from the human factor while guaranteeing data accuracy through software validation rules. This transformation moves the business operational memory from notes on paper to a digital database that can be queried instantly and leaves no room for error. Digital system optimizing the human factor and eliminating operational risk. Yes. Advantage of digitalization in a technical approach. Yes, it's very important. We can examine the technical gains of digitalization under three main headings. First, thanks to real-time data flow, the system generates data at the moment of the event. This allows for immediate intervention when a critical threshold is exceeded, such as cooler failure, preventing large-scale product losses. Second, sensor technologies can detect changes far beyond human sense and manage thousands of data points simultaneously. This scalability is a technical necessity for large enterprises. The third, and perhaps most important advantage, is the transition from a reactive to a proactive structure with AI, of course. While manual systems only record past mistakes, digital systems use algorithms based on a historical data to predict future waste risks. This is very important. This provides the business with a strategic structure that eliminates risk beforehand, rather than constantly being a firefighting position. This is where the human factor comes into play. They must interrupt the data provided, take action, and help complete the process. Resistance from human resources personnel can disrupt a system built with good intention and advanced technology. Food management is no longer a local preference, but a matter of global compliance. The Food and Agriculture Organization of the United Nations, FAO, has identified digitalization as the most fundamental tool under the Sustainable Development Goals SDG 12.3, which aim to halve food loss by 2030. The European Green Deal and the Farm to Fork strategy follow closely as a strategic guide by Turkey, placed the reduction of the environmental impact of food system into a legal framework. Current trends view waste prevention as part of the circular economy model. Digital reporting tools are no longer an option, but a technical necessity for modern business seeking to comply with these regulations. Digitalization provides both a legal guarantee and a strong competitive advantage in the international market for businesses that comply with these global rules. Now, we are coming to our case study. Case study's name is Anadolu Taze. It's a frame. Transition to Digital Monitoring System, the Application Roadmap. In this comprehensive study, where we aim for a technological transformation in the food supply chain, we will address the integration of smart monitoring system into operational process in detail. Through the Anadolu Taze case study, we will deeply examine the technical infrastructure of IoT sensor, RFID tags, and data transformation protocols. By simulating waste data via the dynamic Excel tool we have developed, we will numerically demonstrate the efficiency differences between manual system and digital solution. We will implement all stages from determining technical requirements to conducting return of investment analysis step by step. Focusing on both environmental sustainability and financial profitability, we will work on an innovative management model that eliminates food waste as its source. And we will use Excel sheet and formula after this point. This is our Excel sheet. I will explain this project, transition to digital monitoring system, the application roadmap, with this Excel sheet. First page is contain introduction. The first step of this journey is to fully grasp the roadmap of digital transformation. The instruction page is not just a help text. It's the constitution of the technical analysis process. Here, we see the methodological steps you must follow while transforming your theoretical knowledge into actual filed data. We must manage these four main phases, ranging from current state analysis to return of investment calculation. It's here, but wait. Within a clear hierarchy, we use these steps. Our aim is to use technology not randomly, but within a specific strategy to minimize food waste. This page, Excel page, prevents you from getting lost among technical details by providing a holistic structure of the process. By following these steps with discipline through the training, you will lay the foundation for establishing a data-driven decision-making mechanism in your business. Remember, a well-structured methodology is the greatest guarantee of successful digitalization. As you know, the worst plan is better than no plan at all. Therefore, we should make effective and accurate plans by saying, think it through now so you don't have to think about it later. Now we are coming second page. Inventory audit. Diagnosing the current state. Now we move the most critical section where we take an operational X-ray of our business, the inventory audit tab. Our goal here is to diagnose exactly where and why food losses occur using a scientific approach. We must list product categories in detail from fresh vegetables to frozen goods and honestly evaluate our current tracking methods. As you see, this is our current state. Are we using paper record or simple manual entries? At this point, we concrete the technical bottlenecks created by manual systems. For example, data entries prone to human error, cold chain brushes due to lack of sensors and tracking vulnerabilities. These tabs pose with data which product group is in urgent need of technological intervention. We cannot choose the right technological treatment without a correct diagnosis. Therefore, the accuracy of every data point here will determine the success of the entry system. In third step, we are coming to third step. Technology matrix, mobile apps, RFID tagging, health sensor, eye-powered camera, smart barcode, and etc. After making our diagnosis, it's time to generate solution. The technology matrix page offers a decision support mechanism based entirely on rational and technical criteria rather than emotional or habitual preferences. Here, we evaluate a wide technological range from RFID tags to health sensor and from AI power camera system to cloud-based mobile application. We rate each tool in terms of ease of implementation, initial cost, operational load, and most importantly, the potential to reduce waste. This process allows us to determine the most suitable tailor-made technology set for the specific needs and technical infrastructure of the business. We are not interested in which technology is more popular, but in which one will solve our bottlenecks most efficiently. This objective selection process will allow us to manage the business digital transformation budget in the most strategic way. In this section, in this first technical phase of the application, the focus is on selecting the technological components most suitable for the physical structure for the business and sensitivity of the food groups. Because of this, we do inventory audit and other preparation. In this step, participation must determine which technologies are most sustainable from a technical perspective for a retail chain like the Anadolu Taze case, rather than just choosing the most modern tools. First, the technical specification of the IoT sensor required for cold chain tracking are analyzed. A selection is made based on criteria such as battery life, data transformation distance, and measurement percent to tolerance margin, etc. For example, while high-precision Bluetooth low-energy sensors are preferred for fresh dairy products, the NB IoT narrowband IoT protocol is evaluated for the wide coverage required during the logistic phase. In the second step, a cost-benefit analysis of RFID or smart QR code system is performed for the individual tracking of products. At this stage, it's examining whether the existing infrastructure of the business supports these technologies. For example, the RFID reading capacity of current handheld terminals. During the technical analysis process, the European Union's traceability standards and FAO's digitalization guides are used as primary references point. At the end of this section, a technology architecture diagram is created for the business. A technical draft becomes clear regarding which sensor will be placed where and via which protocol the data will flow the central system. The scalability of the selected tools is of critical importance for the integration into other branches in the later stages of the project. In this stage, the prepared materials and selected technologies are physically implemented in the field. The application is carried out in three main phases with predefined standard operating procedures. In the first phase, the synchronization of existing physical stocks with the digital inventory is ensured. The first digital count is performed using the SKU codes defined for each product group. In the second phase, the IoT sensors are mounted at the designed critical control points. Technical precision is at its highest at this point. Sensors are placed at mid-shelf levels representing the actual temperature of the product, rather than at points receiving direct airflow. Waste simulation, efficiency analysis of digital transformation. Here, as you see, waste simulation, yes. Now we transition from theory to practice and the power of numbers. The waste simulation page is the area where we prove the operational power and efficiency of digitalization with mathematical certainty. Here, We analytically compare manual-based data from traditional systems with target data after digital tools are deployed. The integrate formulas on the page instantly calculate the percentage of which technological tracking reduces waste. This simulation is the concrete answer to the question. If we install this technology, how much food can we save? Here, we personally experience the technical advantages of data-driven performance management. By making weekly data entries, participants will have the chance to observe graphically how digitalization is not just a concept, but how tons of food going to waste are recovered for the economy. This page is the real-time report card of our technical success. In the final stage, yes, we test the sustainability of the project, return of investment analysis. No matter how efficient a technological solution is, it cannot remain permanent in the field if it's not financially sustainable. This step, I'm going to open it, yes. This step is advanced calculating engine that balances the cost of hardware, software, installation, and personal training against the operational savings achieved. Here, we see in how many months the investment will pay for itself and how much net annual gain will provide to the business. The ROI analysis scientifically proves that a technical solution is not just an ethical and environmental choice, but also a highly profitable business investment. Thanks to this page, we can represent the economic logic and long-term financial success of the project to decision makers with data. Digital food monitoring systems, when managed correctly, both protect the world and strengthen the business budget within the economy of universe. Preventing food waste through the power of digital transformation is no longer just a vision, but a concrete technical competency with the data-driven strategies gained with this model. You have taken the most critical step toward building a sustainable food ecosystem in Turkey and globally. Now, the future is yours to transform and lead through technology. Thank you for listening.